Episode 1 of the 4x4 RV build. We got to start off making some parts. To make parts, there's nothing better than a second gen Ram. Everyone's favorite parts trucks. Let's get going on it. Let's start blowing this thing apart. Now this Ram, it was in okay shape. It runs and drives fairly decent. There's a few things that we're going to have to address. We're not going to actually use this engine on our RV project. We're going to be using an older 12 valve with a rotary pump. This is a 24 valve, as Quadzilla and everything else, and we're saving that one for a different project. Now that we got that Ram frame moved out of the way, we're going to pull in our RV. Sounds like a two-stroke, but it's just a 350 with a 4L80. We're not using any of that stuff though. We're not using any of the drivetrain, in fact, on this thing. The entire underside of this is going to be stripped down to the unibody frame. That's right, these are unibody. And it actually works out quite well to stack this unibody frame directly on top of the Ram frame, and they're about the same width. They fit together a lot nicer than you would think. Pulling the engine and transmission and stuff out of these, if you're just using them for parts or whatever, is fairly easy. You just pull them out the bottom. It's probably not the easiest way if you're actually doing an R&R on the engine, but since we're not using any of that crap, I just took it out that way. Now we need to actually remove the front. We're going to call it a removable subframe, but it's removable via a bunch of cutting tools. And then we're also going to remove the back bumper. We're not going to be using that one either. Now it's time for our first test fit. So we'll pull this thing over using our Badland off-road jacks. Those things make rolling cars around your shop pretty easy. And we'll get this thing stuck under there and see what we need to clearance. All right, well, I guess the hoist arms are in the way, so we need to reposition those a little bit. So I got to roll that back out, drop it down, and see if we can't reposition those so we can get this frame underneath it. All right, well, since the frames are so close to the same width, we're actually going to extend the frame to the outside, and instead of doing something temporary, we're going to make something permanent that will end up being our stabilizer jack pocket for when we're parked. So now the next thing that's going to hit is our shock mounts. Then we have a clearance with one of the cross members and our fuel tank. We're going to be using the Ram's fuel tank. And eventually it's going to sit down right flat on the bed rail mounts. That's not how we're going to mount it permanently, but while we get everything set up, it'll keep us nice and flat, one frame to the other. These cross members aren't very thick, so the body saw has no problem just cutting right through them. All right, now we're getting somewhere. The next thing that hits is the frame body mount for the Ram cab is actually hitting the bottom of the generator. And we're not going to use a generator. We're going to be all solar. So here's the hole that I cut for the transmission. That ends up biting me later. And this is where the shocks hit the floor pan. So that's right where your feet are. And the body's sitting right where we want it. So how we're going to fix this is so that we can still service that. We're going to actually have a removable grommet. And that way we can just pull the flooring back and get to the nut with an impact gun or whatever. So obviously we have a wheelbase issue. We're not going to fix the wheelbase on the frame. We're actually going to fix the wheelbase on the RV. I don't like all the overhang, so we're going to take away some of that by moving that wheel well back on the RV. We have plenty of room for the turbo and the exhaust manifold, so that's not going to be an issue. A lot of space to work on the thing from inside with the doghouse off. So one of the biggest hurdles we have on doing the frame swap is the steering box actually needs to be on the outside of the frame instead of the inside. It ends up it's not that big of a deal, but it can be a little overwhelming at first. So what we're going to do is we're not going to use the Ram steering box. We're going to use the Chevy's steering box, and that way it's orientated exactly the way it needs to be. And then we need to make a custom drag link that will connect to the Ram's steering. So this Ram already had 4th gen steering. And then we're going to be using this F250, 350 drag link, and we're going to actually just modify it because it's long and straight for the most part. So we cut it off and then we threaded it. So this will be our part. So I'm going to build a backup part so that I have one on the shelf in case this thing ever wears out. I left it long and I just threaded a section in the center, and that way we can just cut it off and screw it in. And it actually worked perfectly. I was pretty proud of myself for that one because that worked out really, really slick, and it made a kind of complicated job fairly easily. So that's what it looks like. So that's the Ram steering arm on the Chevy steering box, and then our Ford Pitman or drag link connecting the two. So now we need to extend the steering column. So what I did is I actually just combined what was left of the Ram's steering shaft to the Chevy steering shaft and made a coupler in the center that'll still collapse and everything like it's supposed to. And that way we can install it the way it's supposed to be. So Aquila came down. We need to take some weight out of this. This thing came fully furnished, and we need to take all this crap out. Man, there was a lot of it.
But look, there's a closer. Shit.
All right, well, now what I'm making, I'm welding up sway bar in links. So we put the steering box on the outside of the frame, and now the sway bar can't mount where it was originally done from the factory on the Ram. So we're going to use the factory sway bar, and we're actually going to top mount it on the top of the frame instead of the bottom. So we need custom in links. You can buy something like this, but I can make one that's a lot better, and that's what I'm choosing to do. So on the bottom, we have a Heim joint. On the top, we're going to have a stud that will fit. It's a grade 8 stud that's going to fit in the factory bushing on the sway bar itself. So that's what it looks like. I think it turned out pretty cool. Now, since we're Heim joint, we need a straight thread. It used to be a taper, so we need to drill it out, but we're not going to drill it out oversized at all. We want that bolt to be in there as tight as possible. Then we're going to, I'm adding plates to the top of the frame to mount the sway bar bushings to. Probably not 100% necessary. The factory really didn't do that. They just kind of bolted it straight to the frame, but I like to do this, especially in something heavy like this. It's going to have top heavy. I want everything to be as rigid as possible. So there we have it. We bolted it up. This ends up not working out. Spoiler alert. I need to move. I end up moving the sway bar back a little bit, and I end up having to re-drill it a little later. So there's we got our wheels and tires, and then there's our sway bar or steering box that we have temporarily mounted up. We need to make sure it clears, and it's going to clear just fine other than that lug sitting off the side. So that's easy enough. We'll just cut that off. That's probably for a different application or something for that steering box. All these steering boxes and all these rigs, they're all made by Saginaw. They're all the same. Parts are so interchangeable in the two. So now what you see me doing, I'm actually moving the fuse panel over because I'm a manual guy, so this is going to be NV4500, and that our fuse panel is going to be in the way of our clutch pedal, so I'm going to move it over, which means we don't have a e-brake pedal anymore, and that's okay. We're going to just remedy that by putting an electric e-brake in, and that will just eliminate having to have that pedal there altogether. Now we need to patch up the hole in the firewall, and we also need to reinforce the firewall at the same time, and to do that, we're going to use 2024 aluminum, which is an aircraft aluminum. It is tensile strength is equivalent to mild steel. It's pretty incredible stuff. The problem is, and why you don't see it very often, you can't really weld it. It can be welded via friction, and that's about the only way you can weld that. So now all we need to do is add this little tab to the top of the pedal and get it braced up to the steering column. So that'll be the only thing we need to weld on our clutch pedal setup. So that turned out pretty cool. So the firewall was really rigid even without that, but we don't want to fatigue anything, especially considering that that aluminum plate is just bolted on. Granted, it is bolted through the steel and the aluminum at the same time. This is our 12 valve that we got. So this is a 93 12 valve. So it's the best of the rotary pump intercooled 12 valves. This isn't going to be a complete powerhouse, but we are going to add 100 horse injectors. We'll tune up the injection pump and do all that fun stuff. Really greasy and grimy right now. We're going to tear it all the way down, just do an inspection on it. This is actually a low miles, has less than 100K on this engine. And we'll do, obviously, the killer dowel pin, and then we're going to stud it top and bottom. Now, this is one of those situations where the leakier the valve covers, the easier it is to get your injectors out. And they're always just nasty in there. And it sucks, because if you're just doing an injection swap, the amount of crap that goes down into your engine has to be terrible. So I really, really don't like taking injectors out of those unless I'm going to be pulling the head off at the same time. So we are, like I said earlier, we're going to be studding this thing top and bottom. And but I'm going to disassemble this all the way. I don't want any leaks. And in these covers that I just pointed to right there, those covers, side covers, are just notorious leakers. So we're going to replace that with a billet piece, and those will seal up a little bit better. So I'm going to take front cover off and everything because we want to go through this all the way and make sure that there's not any old gaskets on it. The bearings look fantastic. Bearings should look fantastic. That's not something that should be wearing. If you have wearing on your bearing, you need to start looking in other places. So the studs we're using are Exotic. That's the brand. I'll put a link in the description below. I like those. I have good luck with them. And they've been pretty good to me. So we're using those top, bottom, as well as Exotic rocker towers on top. The inside of this motor is clean. It's a very, very clean motor on the inside. Can you believe that the Cummins are only 2-bolt mains with really, really long studs? It just kind of always blows me away that you could easily make 1,000 foot-pounds with this thing, and you're relying on a 2-bolt main. And really, the mains don't fail. The block's split in half. That's the first thing to go when guys putting 100 pounds of boost and stuff in these things. So now we're just cleaning up all the parts. I even cleaned up the old injectors, even though we're not using them. Now to do the rear main, I actually need to take it off the engine stand, so I just use a transmission jack with a rubber pad on it, and that way I can get it leveled to the same as the engine stand, and then we can do the rear main. Doing the rear main on the bench is a hell of a lot easier than doing it in the engine, and we're going to change the gaskets all the way around the housing and everything else. So there's actually a short on that rear main on the YouTube channel. That one was funny. The seal wasn't spinning on the crankshaft, and it wasn't spinning in the housing. The seal had came apart and it was spinning inside of itself. And I think it might have been that way from the factory because there was no wear on the crankshaft at all from the seal. So it was basically like I don't remember what they call them, but some of the newer engines actually have a seal that's intended to do that. This one was not, and so it leaked like a sieve. But anyway, you cannot use enough assembly lube on a camshaft when you're installing it on a tappet style engine. So these do not have roller cams or roller lifters. So you want to oil the crap out of them when you're doing this. So this is the difference between a first gen and a second gen oil pan. The one on the right was the first gen, slightly different shape. And the first gen oil pan will not fit in a second gen chassis, so we have to use the second gen oil pan, and I don't have another pickup tube for it, so we're gonna have to steal the one out of the 24 valve that was in this. This engine we're gonna go through this one as well, so it's not the end of the world. I just have to remember that I need to buy a new pickup tube for it before I go to put that thing back together. So what you see me keep painting on there, that's aviation gasket sealer. So I painted on both sides of the gasket. I've had really, really good luck with not having leaks with that long term. And it works really good. There are cons to it. It's ugly. It's sticky, so it's hard to clean up after you're done. I mean, a little bit of mineral spirits or something will get it off, but it works. So that's why I do it, especially in stuff like this, where we want it to be as reliable as possible. So those are exotic shift rocker towers. The only difference is they're machined a little spot for the head stud, so that way your valve cover will still fit on there. You can machine your factory towers, but I find that it's not worth the effort. They're not super expensive. I've never machined my own set of towers. I've seen some that were ground by hand, and I would highly recommend not doing that. Now I'm going through its two-step process to torque these heads, so I'm using 2 different colors paint pen, one for cycle 1 and one for cycle 2. The valves are going to be the same way, but I just only have to go 1 cycle on these. These are mechanical lifters. There's no hydraulic adjustment. As you see me go through it, you'll see me actually go back through and double check everything as well. I always like to double check doing stuff like this because I don't like doing rocker adjustments in cab. All right, now we're going to do kind of an industrial style paint job on this. I'm cleaning it up. I'm using wax and grease remover. That's meant for auto body. It actually works pretty good if you're going to do cleaning this way without a pressure washer. And then we painted it with Eastwood paint, installed our billet cover, and hopefully we won't have any leaks on this thing whatsoever. So we're also installed what I just installed there. That's an industrial power steering pump. It's a hydraulic pump, but it eliminates the vacuum pump off the engine. And considering the only thing the vacuum pump would be responsible for is running our HVAC controls, we're just going to do a little electric pump for that. So I got the injection pump rebuilt. They locked it top dead center, so it makes timing it a lot easier, and we can just get it in there and line up our marks, and we're good to go. So there's different sets of marks for different timing levels. Lots of videos on that. We won't go into too much detail. So what I did here, this is an industrial air horn from basically a tractor with a Cummins engine in it, and then an aftermarket grid heater, and that's a lower profile. Everything's lower profile and keeping it kind of tighter into the engine so that we can hopefully have easier serviceability on the engine, since that's getting pretty close to the top of the cowling. So when you get your injection pump back from the rebuilder, they lock it into top dead center, so you have to unlock it, and that's what I just did there, and then you just line up your marks. So these aren't adjustable like a P-pump where it has slots. These are basically fixed, and then you have to adjust it just with the teeth and the marks. So now we got our turbo installed. We got our block warmer installed. I don't plan on doing a lot of winter RVing, but you never know, we might need to move it. Now we're installing our 100 horse injectors with our Armite anti-seize. This is a sealer anti-seize. I found it works fairly good at keeping all the crap from making its way down into the injectors. I don't know why those things, just the gaskets on the injectors never seem to last. Even on this one, they didn't last. But again, this is 30 years old. All the injector lines are the factory injector lines, just cleaned up. There's not a lot of options for aftermarket rotary pump injection lines. The Cummins ones are still the best ones that I've found. There's not a lot of good ones. For P-pumps, it's a different story. There's a lot of really good aftermarket lines for P-pumps. And there we have it. That's where we're set up. Now someone might notice that my motor mounts are a little bit farther to the front of the engine than they were on the 24 valve, and that's because we're going to actually move the engine, the entire drivetrain back, and that's going to make it a little bit easier on the front end of this conversion. So this thing's looking pretty good. We still have a couple parts we're waiting for, so that's just going to get pushed to the side for now. So you saw my wiring harness. That's my pinout for the wiring harness. I have one for the gauges and one for the starter and ignition. Very simple harness. So now we're just pressure washing the frame, get it as clean as possible before we bring it back in. I went around that thing probably about literally 10 times, and then I just used the little tractor to push it back in. Now we'll put on the front cover and drive in our seal. This seal is easier to put in while the cover's on. You can use the crankshaft to drive it in if you got the right tooling for it. Now we're going to do all our upgrades to the injection pump, or tuning for the injection pump. This is to compensate for the bigger injectors. So we got to change the governor springs, and then we'll adjust our screws somewhat conservative so that we're not just running around billowing smoke. The injectors tend to on these smoke a little bit, but you can remedy that by some adjustments on the injection pump. That's a very long video just in itself, so we'll go ahead and skip too much detail on that. These are very straightforward to put together and take apart generally. They're not quite as simple as a P-pump though. I like the P-pumps. There's a reason why everyone likes them. They're very cool, but these can be a lot more efficient than a P-pump. They just won't make nearly the power. What you see me measuring there, that's actually just the idle screw, but those are another annoying thing on these rotary pumps, is adjustment of that idle screw is not as easy as it should be. So I measured it before we took it apart, and then I put it back together at the same length. This is me just adjusting the star wheel, getting it to a base point, and putting in our new fuel pin and the diaphragm and all that fun stuff. You have to make sure those are indexed to the right direction or they won't work. You won't have any power whatsoever. So now we got our new valve covers. Love these valve covers. I put finned valve covers on almost everything. Found a fun one. Look at that. It's a backyard weld job if I ever seen one. It worked. It's funny. I didn't notice that until I pressure washed it, and it was so covered in grease and grime that it kind of hid the nastiness of it. The homemade motor mount. It works. It's in the right position, so we'll go ahead and use it. I'm just gonna clean up the welds, grind them down, and then basically just butter them up so they look a little nicer. Now it's time to change hats to be the world's fastest NV4500 rebuilder. There is a ton of really good reference material on NV4500s. The best manual I've used for any transmission so far is the Torque King manual for this NV4500. It is a great manual, and it's a must-have if you want to rebuild one of these. And now we need to shim it. These things, you actually set the lash and the bearings on both the counter shaft and the main shaft. And you just do that with a dial indicator on a magnetic base. And then there's just shims you put in. It's fairly simple. Again, that manual from Torque King will help you a lot. And it'll give you the specs and everything you need. Now we're shimming the main shaft here and getting it within spec. With new bearings and stuff, I like to go on the tight side of the spec. If you're reusing used bearings, then I would go on the loose side of the spec. All right, now it's time for the infamous 5th gear nut on the NV4500. And this is where I go into a little bit of a rant because it's really, really frustrating when you look for information on this. Everyone's blaming the nut, blaming the nut, blaming the nut. The nut is the symptom. It is not the problem. The problem is playing the splines on your 5th gear. For some reason, they machine the shafts so it only has about a half of an inch of splines into your 5th gear. And they make an upgraded main shaft now that's fully splined and it also has a shear washer, a 3-piece shear washer, ensuring that 5th gear won't be able to work back and forth and work that nut off. I also do the upgraded main 5th gear nut just for insurance, but it really isn't necessary. The factory one would be just fine. So now this is a very sad day for me because this is my last one of these. That shift tower is from a UPS truck, and those are pointed forwards and towards the driver. So it's almost like you just flip the shifter around, except it's pointing towards the driver instead of the passenger, which would be what would happen if you just flipped a standard shifter around. That's my last one. I don't know where to get them. I have not found those for sale anywhere. This is the precious NP241 DLD that come in the back of these Rams. My least favorite transfer case of all times. They absolutely blow my mind that they even work with the thin, paper thin cases that they have. In fact, it was so thin that the rear on this one, I had to replace it. It was split and spread open. So we had to replace that, and then we'll use a case saver, which is supposed to help keep that from happening, but I'm not sure if it'll actually work or not. I haven't had really good luck with these. They're not my favorite transfer case in the world, but it's a placeholder until we can put an Atlas in later. All right, this is that case saver. It basically is just machined, and it has a leg that goes into the groove, and then you just tighten it around there. It's just supposed to be stronger and sheer than the lock ring is. Now I did set the motor in, not on camera, and it is set farther rear. So it turns out that we could have used that 1st gen oil pan doing it this way. But this is going to get the engine farther back in the chassis, which will be good. And now we'll just get the clutch installed. I'm just reusing the clutch. The guy had just put that clutch in there before I got it. So I'm just reusing it. I don't usually use used clutches, but there's no sense in buying a new one. That one was still in really good shape. So I got the transmission on there and bolted up. Things like this make me wonder, did I actually tighten that other side? Now I have to go check because I don't have it on video. It looks like I only tightened the one side, and I'm actually genuinely curious whether I did or not now that I'm editing a video. Transfer cases, the nice part about those things being paper thin is they're real light, so it's easy to just stick them in there. Now we're getting into doing a little bit of fab. So I'm measuring up the crossmember. The crossmembers on these Rams are awful. They're installed from the top in a wedge. So they're a pain to take out the bottom, and unfortunately that's kind of how you have to do it. A lot of guys will jack the frames spread apart, and all that stuff. Anyway, we're going to build a mount that's actually removable, and of course, because we moved the engine back, we also have to offset that to the rear. So using the arc droid, this is just real thin sheet metal. I'm just doing this as just a test fit to make sure that the bolt pattern fits both sides and that we got it right, since none of it is actually square. It fit perfectly, so we're good. We're good to go. It fits on both sides, so that is a mirror image on both sides. So now we're going to be cutting it out of 3/8 plate. This is a leftover project from the past that I'm able to reuse some of the sections of it. These are the ears that our mount's going to be on. We are going to rubber mount this. It's not necessary to do that because the transmission also has a rubber mount, but this will allow the frame to move around a little bit and not create any cracks, having it be a little bit flexible. There they are. I do have to make a little bit of a clearance for the head of the bolt so it's actually tightening onto the plate and not onto the corner of the bolt on the weld there. So now when we remove this cross member, we no longer have to take those bolts off the side. Now we just have to take the one bolt out of the center. And these are just urethane bushings and a piece of DOM tubing that I use quite often when doing conversions like this. Sometimes when I fabricate stuff, I like to just wing it. And that's what I'm doing on this one. Instead of going under there and doing a ton of measuring and everything else, figure out offsets and angles, I just built this thing long. And I'm just going to keep adjusting the angles until the thing matches up. And we'll just make it mirror image from one side to the other. And then once we confirm that we have enough angle, then that's when we'll go ahead and fit it in between our bushings there. All right, so that worked out absolutely perfectly. So we'll just tack it in there. We'll weld it up and add some more parts to it once we get everything else fit. So now we just need to make sure the transmission's centered. And then we'll design a plate up using our little 2D software here. This is called DraftSight. It's the same people that make SolidWorks engineering software. This is just a very simple 2D drawings platform. I like it. I hope they don't make it. They're starting to add features to it, and I don't like that. I just want them to keep this as simple as possible. But it is what it is. But I hope that they make it simple and stop adding features to it to try to make it, compete with their own software that they already have, which is SolidWorks, which is a 3D design software. So that worked out perfectly. So now we just tack that on there, and then we just add some braces and some gussets, and we'll be good to go to weld this thing out. All right, we'll take our bushings out so we can do our welding, and then we'll design up a fish plate for our cross member for the joints in the cross member itself. So those are pretty simple to design. And then I designed up a little gusset, and that gusset will be in the middle of our transfer case mount on the little plate there that we got in the middle. Now for the world's fastest weld job. And then we'll go ahead and clean it all up and get it ready for paint at the same time. What I use to paint this stuff is Rust-Oleum Flat Black Professional. It has to be the Professional tall can. It's the best flat black I've ever had. It matches, and you can touch it up in the future, and it'll match again. It's a really, really good flat black, especially for just a spray can, aerosol can. Now we'll install our front drive line, and that is a factory automatic front drive line. That fit perfectly when we repositioned that motor to the front set of mounts and moved everything back. The automatic driveline now works on the manual. The rear, I believe, could have been a factory automatic rear driveline, but I already had a brand new one for the manual. So I just had it chopped down and rebalanced. But in the end, I think this thing turned out pretty darn good. So this is where I lost some of my video, so I'm having to use my iPhone videos, so I apologize for the narrow field of vision. So this is where I moved the sway bar back. Remember when I said I had to move it later? We moved the sway bar back, and this is where I'm adding pipes going through the frame to mount the steering box. So that's what it ended up looking like now that we're committed to it. So now it's nice and flat. I just bolted those to the box, drilled the holes in our Swiss cheese frame rail there, and welded them in. And here's a good look at it, all assembled. So you can kind of see what we got going on there. Again, sorry for the narrow field of vision, but it is what it is. I lost an entire SIM card on this build for this period, which is absolutely terrible. Anyway, it looks good. There's our inlinks, new bushings, and all that fun stuff. Everything clears, and we're good to go. That's going to end it for this episode. Episode 2 will be out tomorrow if you're watching these live. Otherwise, it'll be linked here right at the end. Thanks for watching. We'll see you on the next one.